Hi, in this video we are going to talk about simplifying radical expressions. Those are going to be the ones with the square roots. Those are the most common ones, and you need to understand how to do them. So, first of all, what is the property that we rely on? The square root of a squared is going to be the absolute value of a. We deal with the principal square root, which is always going to be positive or zero. And I need to explain this common misconception that I want to make sure that you avoid. Square root of 4 squared is going to be 4, but the square root of negative 4 squared does not equal negative 4. This cannot be done because that contradicts. The principal square root has to be positive, cannot be negative. Now if you put the absolute value here, so if you do the square root of negative 4 squared and you write the absolute value of negative 4, then you get 4 and everything is correct. Now that's fine. So simplify square root of 121a squared. Square root of 121 is going to be 11. Square root of a squared, as we already know, is going to be the absolute value of a. So it's going to be 11 absolute value of a. Okay. Square root of 12b squared. So what do we need to do here? Again, we have b squared. We know that's going to be absolute value of b. And so we're going to have a square root of 12 times the absolute value of b. Square root of 12 can be simplified. I hope you know how to do that. So it's 2 square root of 3 times the absolute value of b. Square root of 45c squared. We can simplify square root of 45, and c squared will give us absolute value of c. So square root of 45 is going to give us 3 square root of 5 times the absolute value of c. And square root of 19p squared, we cannot simplify square root of 19. 19 is actually a prime number, so it's just going to stay as a square root of 19, but it's going to have p, absolute value of p. Okay, so far it's pretty straightforward, but of course what's going to happen when you go to higher powers of a? You're going to say, well, what about a cubed or a to the fourth or a to the fifth? How do we handle that? Because our property only helps us do that with square roots. Well, when you have square root of 81 a cubed, what you're going to do is the following. So you're going to write 81, and then a cubed is going to be written as a squared times a. A squared times a is a cubed. Then we're going to have square root of 81 times the square root of a squared times the square root of a. Square root of 81 gives us 9. Square root of a squared will give us absolute value of a, and square root of a is just going to stay like that. So that's going to be our answer here. There is not much you can do. Okay, we just rewrite that. So it's 9 times the absolute value of a times the square root of a. Okay, what happens when you get to m to the fourth? Well, if we do the same thing, we're going to have square root of 24 times the square root of m squared times the square root of m squared. M squared times m squared will give us m to the fourth, right? Square root of 24 is not going to give you a whole value, but we can simplify it. It is going to be what? It's going to be 2 square root of 6. So now what are you getting here? You have square root of m squared, which is supposedly going to give us absolute value of m. And then you have another square root of m squared, which is also give you absolute value of m. But here's the thing here. You don't need to leave it like that, because this is a positive number, this is a positive number. But when you multiply a number times itself, you will always get a positive result. So this here can simply combine to m squared, and you'll no longer need to write the absolute value sign. Okay, because you multiply positive because m squared, regardless of what m is going to be positive, or 0 if m is 0. So when you try to do square root of p to the fifth, what are you going to do then? You're going to break it up into, you're trying to see how many times you can pull p squared out of that. So what we're going to do is we're going to have square root of 160 times square root of p squared times another square root of p squared. That's right now takes us to p to the fourth, so we need one more p, right? So what do we have here? Square root of 160 can simplify. It's going to be 4 square root of 10. Now this one here is going to give you absolute value of p. Another radical here will give you another absolute value of p. And there's going to be one more square root of p that's going to be left. Again, just like here, we multiply square root of p by square root of p. I'm sorry, absolute value of p times the absolute value of p. It's p squared, and you no longer need the absolute value sign. So we're going to have 4 square root of 10 times p squared times the square root of p. But here's one thing that's a little different about this problem. You have two square roots left here, one with 10, one with p. So what we're going to need to do is we're going to have to write 4p squared and combine those two together, 10p. Okay? Alright, now we're going to see combinations of more than one variable, and let's see how we're going to handle that. So 150 square root of 150 times square root of, so we're going to do a squared times square root of a squared again times square root of b squared times b squared, that's 4th power, times square root of b squared again, that's 6th power, so we need one more square root of b. Square root of 150 will simplify to 5 square root of 6. This is going to give us a absolute value of a times the absolute value of a, right? It's going to give you the absolute value of b times the absolute value of b times another absolute value of b times the square root of b. So we're going to have 5 square root of 6. A times a is going to give us a squared. It's an even power. We no longer need the absolute value. So a squared times b. Now multiply b by b by b, absolute value, that's going to give us b to the third. That's an odd power. You potentially can have a negative value there, so we're going to have the absolute value of b cubed times the square root of b. So let's assemble all the square roots together. Your answer is going to be 5a squared absolute value of b to the third times the square root of 6b. To make it easier to understand, what you generally need to view it as, when you do these types of problems, you want to see how many times, like in this case 2 goes into this exponent here, and then you can actually understand what's going to be remaining. So same thing here, square root of 72 times square root of p squared times square root of p times square root of q squared and the square root of q squared times the square root of q squared, that's 246, times the square root of r. Square root of 72 simplifies to 6 square root of 2. Oh, I'm missing a square. Oh, no, I'm not missing a square. Here, I'm good. That's 1. So it's going to be the absolute value of p times the square root of p times, so here we have absolute value of q times the absolute value of q times the absolute value of q. We're going to have 3 of them times the square root of r. So what is all this going to give us? We have 6 square root of 2. We have the absolute value of p. We have the square root of p. 3 of them, odd power, so we're going to need the absolute value sign, absolute value of q cubed, times the square root of r. So assembling all these together, 6 absolute value of p times the square root of p times the absolute value of q to the third times the square root of 2r. Square root of 144x squared y to the fifth. It's going to be a square root of 144 times the square root of x squared times the square root of y squared times the square root of y squared times 4. There's one more. 144 is a perfect square, so it's going to give us 12 times the absolute value of x times the absolute value of x times the absolute value of y times the square root of y. So what do we get here? It's going to be, nope, hold on, there's only one, hold on, it's x squared, so it's x, this one's supposed to be y. My apologies. So it's absolute value of x from here, and then absolute value of y and absolute value of y. So you multiply absolute value of y times the absolute value of y, you no longer need the absolute value there. So it's going to give us 12 times the absolute value of x times y squared times the square root of y. Okay. And moving on. So a few more examples. You sometimes have a situation when there is also a number in front. So what do we have here? We're going to have 5 times the square root of 81 times the square root of w squared times the square root of w squared times the square root of w times the square root of z to the second power, square root of z squared, square root of z squared, and the square root of z squared. Now you should probably begin to understand that if 2 goes into z an even number of times, then you are actually not going to need the absolute value. But let's see. So 81 is, the square root of 81 is 9. So it's 5 times 9. That's the absolute value of w. That's another absolute value of w. It's the square root of w. That's an absolute value of z. Times the absolute value of z times the absolute value of z times the absolute value of z. So what is this going to give us? It's going to be 45. Multiply w, absolute value of w times the absolute value of w. No longer need the absolute value of w. I'm going to put this radical at the end. Z, 4 of them. It's an even exponent. You don't need the absolute value anymore. And it's going to be z to the fourth times the square root of w. I do want to make one point here. When do you actually need to keep the absolute value? Because there are some problems, and I'm going to go back and show you some problems. Because if we know that we're going to be left with an absolute value of w, that means w has to be a number that's not going to be negative anyway. So in this case, whether or not I had these even exponents, I still would not have needed those absolute values because of that. Let me show you this example. So 3 times the square root of 40 times the square root of m squared times the square root of m squared, no, just m to the first, times the square root of p. So the square root of 40 can simplify to 2 square root of 10. So it's 3 times 2 times square root of 10 times the absolute value of m times square root of m times square root of p. So this is what I was talking about. It looks like we need to keep this absolute value here, but take a look at this. This here implies that m has to be a 0 or a positive number. So that means that this here, the absolute value of that number, will always be positive anyway, and you actually don't need to keep the absolute value of m here, because the implication here is m is going to be greater than or equal to 0. So since this is already positive, you don't need the absolute value here. So it's going to be 6m times the square root of 10mp. Okay. And this last problem, so we have 7 times the square root of 14 times the square root of c squared times another square root of c squared times the square root of c times the square root of, absolute value of d. Alright? So it is 7, nothing we can do with the square root of 14, it's going to stay like that, times the absolute value of c, times another absolute value of c, times square root of c, times the absolute value of d. So we're going to get 7, that's going to give us c squared, that's going to give us absolute value of d, and then it's going to be the square root of 14c. Okay. So I said that I was going to revisit a few problems with regards to what I mentioned here, and you have to be very, very careful, because in some cases it's going to be irrelevant. So let me show you number 8. So in number 8 we have this absolute value of b cubed, but do you really need that? Well, no, because when you look here, since we have an odd power of b, then b cannot be negative anyway. Because if b is going to be negative and you raise it to an odd power, it's going to be negative and you're going to end up getting a negative number here. So we should realize that b has to be greater than or equal to 0. Not a, because a has an even exponent, so whether a is positive or negative, you're still going to have a positive number. That means we don't need the absolute value here, and the answer is going to be 5a squared times b cubed times the square root of 6b. Okay? And then there are some other problems where the same thing is going to be possible. Okay? So anyway, I hope this was helpful.